I want to go over this latest assignment where we talked about the law of cosines. And we have these problems aren't limited to the law of cosines. They're just some problems involving the law of sines and the law of cosines. But first of all, let's just look at this first one. Now, I've got it all written out here, but I just want to kind of walk you through how I think about this. For example, this first one, all we're asked to do is find this angle, ACB. And what I've done here to help you, I've got these, I drew a little parallel line. Now, this is meant to be parallel to these two. Okay, so I didn't really make that clear. But if you do notice, if you do view this line as parallel to this one, what you've got here are two lines cut by transversal. And I've drawn that out over here, okay? Two lines cut by transversal. And if you look at it that way, then you remember that alternate interior angles are congruent. So that tells you that this angle here is 45 degrees, and likewise this angle would be 35 degrees because this line and this line are parallel. So that's the way we can get started on this one. And once we do that, it's just a matter of adding those two angles up, 45 plus 35. So really that didn't have any trig in it. It's just a little bit of geometry is all that was. Now this other one, I've drawn it out here, and could be I made some computational errors. I don't think so, but this is the way it's going to look. We have that Rugby walks at a bearing of south 27 degrees east. So this is him over here. He's going this way. And this angle here is the 27 degrees. Okay. And then Cecil walks north 30 degrees west. So he's 30 degrees, actually, I guess I should say 30 degrees west of north. And that would be this right here, that angle. Okay. Now, I went ahead and I drew it out over here. I got it out of the clutter a little bit. And one of the things they said, Rugby was walking at 3 miles an hour. That's every 20 minutes he'll walk a mile. So that means in 10 minutes he will have walked half a mile. So that's how I got that right there, the half. And then the other one is walking at 4 miles an hour. That means every 15 minutes he'll walk a mile. So in 10 minutes he walks 2/3 of a mile. Yeah, so I got those sides of the triangle. Now, I needed to get this angle because what I'm going to need to do is I'm going to need to use the law of cosines to get this side right here. I'm going to need to use the law of cosines. And I've got the two sides, but I need the included angle. Well, so here's what we've got. Notice that if you think about this part of the angle right here, this is 180 minus it's going to be 90 minus 30, right? So 90 minus 30, ooh, look what I did. I messed up here. I've got 90 minus 30 is 50, but 90 minus 30, that would be 60. Where did I get 50 here? Okay, there's 60. Okay, so this is going to make this a 177. Okay, so I messed up there. But this angle here is 60 degrees. And then from here over, this is 90. And then this other angle is 27. So we've got 60 plus 90 plus 27. So I would need to make a change over here to what I did. This is going to be 177. Okay, 177. And so I need to recalculate that. But anyway, so let me make this. Sorry about this. It's actually good to make mistakes because, it's part of the process. It's good when you catch them. Before you start the video, it'd be nice. Okay, so there it is. So once you work that out, you would have the length that you're looking for. Okay, now the next one, person looks up at and down there at their feet, the angle of elevation up to this aircraft is 75 degrees. Okay, 1 minute later, the angle of elevation is 25 degrees. So the jet's moving along, and it's 30,000 feet up. So I've got the overall thing drawn right here. I've got the overall problem. This is 75 degrees here, and then this is 25 degrees. So I've got it all drawn there, but it's kind of cluttered. It's got a lot of clutter. So what I've done is I've made it into two triangles over here just so that we could see what's going on. And one of the things I need to do, I need to label. What I want to know, the idea is we want to find out, okay, in 1 minute the plane flew this far, or in other words, this far right here. I need to figure out what that is. And if I can figure out how far that aircraft went in a minute, well, that's his speed right there. So I noticed that I can use tangent. So look over here. I've got tangent of 75 degrees equals 30,000 over x. So I just solve for x, and I get x equals 30,000 over tan of 75. I do that same thing over here for this triangle when I've got tan of 25 degrees equals 30,000 over x plus y. Okay. Now, I just do a little bit of algebra, and I get that, y equals 30,000 over tangent 25 minus x, but my x is 30,000 over tan of 75. Now that's what y is, and if you go along, if you calculate that, what you're going to get is feet per minute. If you multiply that by 60, you'll get feet per hour, and then divide that by 5,280, you get miles per hour, which that's what I went with. Okay, now this next one is an ambiguous case, as is clear by this donkey, right? Okay, so we know that there might be no solution, there might be one solution, there might be two solutions. We'll find out soon enough if there's no solution, because we'll get a case where we try to take the inverse sine of something bigger than 1, a number bigger than 1. But there could be two solutions. So here's what you do. You take, remember the test, we do b sine A, and that needs to be less than A, less than B, like that. And if that happens, then there's two solutions, and it does. For this one, yeah, there are two solutions. So I just go about finding the first solution, and that's pretty straightforward here. But the second solution, remember, here's the way we jump off. We transition from the first solution to the second solution by looking at the missing angle. We've got the side B. We want, our transition is that angle. We're given angle A, side B. We're going to start with angle B. So we do this. We do 180 minus the old angle B. See? So dig this. 180 minus this thing. Now, after we do that, everything is good. we get 148.8. Then I can find big C by doing 180 minus A and the new B. And then I can find wee C, the new C, okay? And there we get those. We get all those. Now, these next problems, we're just solving these by graphing. Now, these particular problems were just some that harken back to the previous assignment, well, I guess a few assignments back. But I just put these on here. We're just solving these by graphing. This part C right here, we're just finding where is 1 over x sine x less than or equal to 0.1. And I graphed that. I've got 0.1 there, and you can see where it starts to dip below the 0.1. Okay. Now, the rest of these, I think, are pretty straightforward. We're just solving the triangle. Here on this one, it's a side, so I'm going to use law of cosines. I have no choice on that because law of sines, you need at least one angle, and I don't have any. So I'm going to find alpha, beta, and gamma here. Okay, so just very straightforward using the formula. That's all there is to it. Now, once you find two of those, you could do 180 minus the sum of those two and get the other. Now, this next one is another law of cosine. We've got an angle, and then we've got its adjacent sides. So we use the law of cosines. Okay. Now, the last one is another law of sines, and it's an ambiguous case. So that tells us we could possibly have two solutions. But if you look at this, A is 65 degrees, and it's got a short side opposite it, 4. Compared to B, which is 25, that tells you that there may be a problem if you're trying to draw a triangle with these dimensions. So that clues you in, but you don't have to think about it. You just set up your law of sines, and you find that sine B is 5.6. That can't happen. So you know there's no solution.